Thanks to Carola for giving us a great introduction, and thanks for us being invited. We've been headlined as Glenalmond Timber, but just to confuse you all, we're both here representing Intelligent Wood Systems because we're the R&D arm of our parent company, Glenalmond Timber. So we're trying to find ways of utilizing timber more efficiently and maybe more creatively. So with timber construction, Carol has pretty much touched on most of it anyway. There's always questions. Engineers, clients, building designers, they choose their building materials for various reasons. It could be the strength, the performance, the aesthetics. Cost comes into it. Durability, usability on site. How easy is it to access and erect? Planning stipulations, some restrictions. There's personal preference. And there's claims by sales literature and people like me. All these things are covered when you're making that decision process, but there's still that grey area of fire. When we talk to people, people say, oh, wood burns, and that's it. They shut you off straight away. And tonight's agenda is about can we replace more traditional products with plant-based products? And I believe we can. So does timber burn? Yes, it does. Anything with a wood fibre in it has potential to burn. We're not going to deny that, but can we manage it? Quite customers will ask, should I use alternatives? We don't really want them to, but the options are concrete. But at 300 degrees, concrete begins to lose its compressive strength. So there's a fire, it's not performing that well. When you hit 1,000 degrees, which is easily achieved in a construction site fire, you're also losing the stiffness within the rebar. The pink sort of glaze on that concrete foundation there tells you that it's lost all its strength. So maybe you don't consider concrete. Maybe you consider steel. At 300 degrees, steel properties begin to degrade. 550 degrees, you can get buckling and collapse. That picture there is a very old famous picture. The curved items you can see are still RSJs. The nice straight bit at the top is a solid steel beam. That's after a very extreme fire. Metal, when it gets hot, it can drip. That melted steel can create secondary fires. People use light gauge steel inside instead of timber stud walls. But at 900 degrees, light gauge steel loses 87% of its structural performance. So it's maybe not always the best thing to move away from timber just because of fire. Basics, what is fire? It's three things put together so you get a chain reaction. You need heat, something to set fire to it. It could be malicious, it could be genuine mistake with hot works on a site. You need a fuel, could be a combustible item, a solid, a liquid, or a gas. Everybody always just says it's timber. Oxygen, when we've got these construction sites, they're all outside. So when we get this combination of three things, we get oxidation, which you and I call fire. When we see fire tested and trying to prove fire, there's lots of terminology. So when we see flame on a piece of wood, that's just the internal gases igniting. That's what that is when you see that lovely orange flame. The mass timber guys will talk about char. If you've got a thick piece of timber and it's burning and it takes the moisture out, it forms a crust. That crust is nature's way of sealing in the gases. So the gases can't come out, they can't ignite. So they talk about char rates. Radiant heat's a big thing. When wood burns, it chucks off a lot of heat. So when we talk about that, it's just that heat coming off the surface. Flame spread, when you see a fire break through and it travels in all directions, that's just the flame spread. And flashover. Flashover is a big thing. If something's burning within a room, the gases it gives off will collect in the top of that room. And when the heat gets to a level, it will self-combust, you'll get a big sheet of flame. That's known as flashover. If you watch the movie Backdraft, that's all about flashover. Now, these things are all relevant in the way we specify timber. We essentially have two types of fire. We have during construction, and the challenge then is, can we manage that fire? That's a building site. As you can see, lots of raw material, lots of air. If that catches fire, can we manage it? Or in service, when we get lots of architects and engineers talking about fire performance, 30 or 60 minutes, that's considering the finished building, when everything's in place, your plasterboard's in, your doors and your windows. And essentially that's saying, how long can I sit inside this room before the fire gets to me? Is it 30 minutes? Is it 60 minutes? And that will consider the sum of the parts within that structure, not just one element, all of the elements. So when we talk about during construction, it's when it's at a skeletal stage. So the STA, the Structural Timber Association in the UK, can be considered to be world leaders in this. Light frame or timber frame, as we call it. So you've got small timber membranes clad with a sheathing, which could be plasterboard, with plywood or OSB. It's very, very combustible. So they build this pod. It's to look like a building site. It has a window opening, has a door opening, has no insulation, no drywall, no windows, no doors. It has a dwarf wall above to represent the second story of a house, and it has a wall to the right-hand side to represent your next door neighbour. So when it's during this constructional stage, they put an awful lot of fire in it. It's usually averaging about 985 degrees in there. Quite often it exceeds 1,000 degrees. And the challenge is to keep the structural integrity within that box so everybody else can do their job. We have to add chemicals. Timber doesn't do it on its own. So there's special chemicals out there, but it doesn't damage the timber. It will make it harder to light. It will slow down the spread of flame, and it will reduce the radiant heat. These things are important. If you can reduce the ignition time, so it takes longer to ignite and it spreads slower, the first thing is it allows people to safely escape that building site. The second thing is it gives time for the fire department to turn up. And if you reduce the radiant heat, they can get a little bit closer to actually fight the fire and save your building. Important then that we can retain the structural integrity. So that's during construction. The second one is in service. So it considers full wall assemblies. So that's a whole wall that's put across the face of a furnace. And they actually introduce an awful lot more heat. It's basically big sheets of flame hitting the face. And the temperature is measured on the outside. What it's looking for is to keep the temperature to a minimum or to avoid any breakouts. That's an in-service fire test. We measure this in minutes. Can you get 30 minutes? Can you get 60 minutes? That's answering that question that the architects and engineers ask. If you're not doing a full in-service component test, you can do individual tests. Oh, sorry, I've skipped a slide. So if we're using mass timber, so with a CLT that Carol has mentioned, you can encapsulate it with drywall. You don't have a fire risk. But if you're buying this beautiful piece of timber, a lot of people want it exposed. So we have to use what they call charring rates. We can't rely on plasterboard because it looks ugly. So the charring rates are a calculation. The structural design is done on the panel. It will tell you it's going to be 100 mil, 120, 200 mil thick. That's the structural calculation only. Then a fire engineer will specify the char zone. That's how much sacrificial timber can be on that. So should the building catch fire, you'll keep your structural integrity and the char will help slow down the fire and the fire department will put it out. A rough rule of thumb is 25 mil on every exposed face should equal 30 minutes. That's just a rough guide. Your fire engineer will give you the exact number on every design. So if you're not doing a full wall, you can go and get individual components, normally claddings, tested. So you take the individual item, you form a small panel, and you introduce heat to the face. The measurements and observations are always taken from one face. They don't take any measurements from the rear. This gives you an idea. Non-combustible materials are A1 and A2. Nothing with a wood fibre in it will achieve the A's, but you get to the B's. The B's are the next best thing to non-combustible. So this is a Euroclass rating. So when we see the ratings, they'll be in three parts. B is the category it falls into. So B is combustible materials with very limited contribution to fire. The S is a rating on the fire spread, and the D is droplets. Has anything dropped off and contributed to starting or continuing the fire? In this case, 0. If you can get a B, S1, D0 on timber products, it's a very, very good product. To give you a quick idea, I won't make you endure it all. I will jump through it. So this is cladding on the outside of a building. Heat is introduced to the face. There's an awful lot of heat there, and the idea is that that timber on the face of the panel, the outside of a building, won't contribute and allow the fire to spread. You can see the lighter coloured one. We've got some fire on the surface now, but it's not travelling. So the flame's not quite as impressive now, but there's an awful lot of heat within that crib. As you can see, the localized area of the fire, but it's not burnt through and it's not spread, and there's nothing dropping off it to create other fires. That's over 7 minutes now of an intense burn against the face. Yes, we have some superficial damage, but we're not compromising the building or the buildings in and around it. It just gives you an idea of how these tests are conducted. We can show you more at a later stage should you wish. So I'm trying to keep it as quick as possible. Timber and timber-related products will burn. So the naysayers who say don't use timber, they have a point. But timber's no worse than the other safer options in its natural state. Plus, we get the opportunity to add chemicals and design the risks out. So timber is a really good product in relation to fire. People just don't appreciate it. As an industry, led by the Structural Timber Association in the UK, we're continuing to develop solutions. We're market leaders in this in the world. We know large companies from North America are looking to copy the work that the STA have done in the UK. So timber's an old material. It's been around for donkey's years, but it can be the green material of the future. That's it. Thank you for your time. Any questions?